Welcome to another video from explainingcomputers.com. This time it's very exciting indeed because I've just purchased this, a Monoprice Mini Select V2 3D printer. And compared to most 3D printers, this is a low cost and compact model, despite the size of this box. And in this video, I'm going to be setting this up and also talking about the practicalities of budget 3D printing and explaining the basic 3D printing workflow. So let's go and take a closer look. Right, here we have the Monoprice Select Mini V2, which is officially priced at about $190 or £185. However, the price varies greatly, so I advise shopping around. So for example, I paid £129.49 for this printer from Monoprice Co UK, and I also paid £17.24 for this 1 kilogram spool of PLA 3D printing filament. So for less than £150 delivered, I got the filament and the printer, which I think is pretty good value. And just before I open this up, I want to point out that whilst this is the first 3D printer I've ever owned, it's far from the first 3D printer I've ever used or have broader experience of. And this is because between about 2012 and 2017, I did a lot of 3D printing research, including publishing these books and doing various consultancy projects for clients. And I also tested out many different 3D printers, including the excellent Ultimaker 2. But finally I decided I'd like to have a small 3D printer myself, and here it is. So let's get inside, let's bring in Stanley the knife and open it up. Rather a big box for me to be unboxing, which is why I'm unboxing it on the floor. And oh, inside the box is another box. And there we are, I've got box 2 out of box 1. What does it say? Read before unpacking your printer. Do not return to the reseller if you purchase from. I don't care. Let's get on with the unboxing and bring in Stanley the knife again. We see 3D printer things. We've got a manual, that type of stuff in there. That's exciting. When the whole thing is in polystyrene. Let's do that. We have a small bit of filament. You can see the back of the printer. This is probably the power supply, I would guess. And is it going to come out? Which way are we supposed to be going? That is the back, isn't it? I've got it out backwards. Never mind, it'll still be okay. Let's get it out the polystyrene. Oh, there we are, it's coming out. Not my best of unboxings this, is it? But never mind. Please come out. There we are. Finally, I've got out the 3D printer. And I think what I'm now going to do is to take this and all of the accessories from the box and to put them carefully on the desk. Right, here we have the printer, which has a nice solid metal body. We also have its power adapter and lead, the manual and the supplied sample filament. However, as I've purchased a much larger spool of exactly the same material, I'm going to be printing with that. We also have a scraper, a spool holder that will slot into the printer in a second, a hex key for leveling the print bed, and a USB lead and a microSD card that plug into the printer down here. Files for printing can be supplied to the Select Mini on a microSD card, via Wi-Fi or over USB from a computer that has to remain connected during printing. The Select Mini builds objects using a 3D printing process called material extrusion, with the spool holder going onto the side of the printer like this. It just slots in like that, and we put a spool of filament onto the holder like that. And then the filament comes up here to this feed mechanism that pushes it down this tube to the hot end, where it is extruded onto the build platform, also known as the print bed. This is also heated so that the object being printed will cool more slowly, which helps to prevent warping and to improve adhesion to the build platform. The build volume of a Select Mini V2 is relatively small, at 120mm or 4.7 inches cubed. This inevitably limits the size of objects that can be fabricated in one piece. However, it also makes the printer easier to store. Indeed, with the filament spool and holder removed, overall dimensions are no more than 11.5 by 8 by 14.5 inches, or roughly 29 by 20 by 36.5 centimetres. And the weight of the printer is just 4.5 kilograms. When purchasing any lower cost 3D printer, it needs to be understood that effortless click and print is not yet available on any printer that costs a few $100s or pounds. So, regular calibration, maintenance and experimentation will be required to get good results. Like all low-cost 3D printers, the Select Mini V2 has some known issues, and my advice when buying any 3D printer is to research its shortcomings before purchase so that you go into things with your eyes wide open. Alongside price and size, one of the reasons I chose this particular printer is that it's got a great online support community and that spare parts are readily available. Specific issues with the Select Mini V2 are that the plastic build surface on its build platform, known as build tack, will need to be replaced at some point, with some owners opting to upgrade to a glass bed. Secondly, the lever in the feed mechanism is apparently prone to breaking. It is, however, possible to print a new one yourself, and so this is something I intend to do as soon as possible. Thirdly, I've seen many reports that the wiring for the heated bed is routed in such a manner that it causes it to chafe and fail. However, on this particular printer, the wires are secured differently to what I've seen in many videos and photographs, and they're protected by an outer sheath. So the design has clearly been improved, although I'll keep an eye on this and reroute the wiring if there's a problem. Finally, it should be noted that the printer's microSD card reader is only compatible with standard SD cards and not SDHC or SDXC. So, if you want to print from microSD card, it's worth shopping around to get one of the older cards as a backup. Greetings! We're now all ready to roll, so I'm going to turn the printer on. I've plugged it in, and if I do that, it's got some power in the machine. Oh yes, there's something on the screen. And the first thing we need to do is to level the print bed. So we need to go across to move, using this little control here like that. We need to go to home, which is over there. There's home like that. Oh, things are happening. And the printer has now moved to its home position. So we need to turn it off, which means that we can move the build platform around without doing any damage. And we need to take a small piece of paper and we need to slide it between the extruder and the build platform. And it should just go in, but there should be a little bit of tension, which there isn't at the moment. So we need to adjust that using the little hex key we've got here. So I'll get on with that. There we are, that corner's okay, so we'll move on to the other corners. And there we are, after quite a bit of adjusting with the hex key, I think I've got that bed level. And I cannot overstress how important it is to get the bed level and to regularly check that the bed is level. So, I'm now going to insert the microSD card into the printer before grabbing Mr. Scissors to cut the end of the filament at an angle to create a nice point. We'll then feed the filament into the feed mechanism by pulling back the lever like this and pushing it through, and there it goes down the tube, technically known as a Bowden tube, and we push it until it meets resistance, which is about there. That's met resistance, and the filament we're using here is PLA, or polylactic acid, which is a bioplastic that does not emit toxic fumes when printing. Next, we'll turn the printer back on and select preheat on the menu like that, and we're going to set the nozzle temperature to 205, which is pretty typical for PLA, And we're also going to set the bed temperature, which is over there like that, to I think 55, which again should be okay for PLA. With everything warmed up, we're going to extrude a little filament to check everything is working. So in the menu we will go back like that and go to move. And first of all, we're going to go to the Z-axis to actually move the Z-axis up a bit, so we've actually got some space. So we'll go like this. There we are. And if we go across to extruder, we should now be able to extrude some filament. And it looks like a tiny thread has come through already. Let's just move that through. There we are. Looks to me like there was some filament that had been used maybe to test the printer, a black colour, but clearly there our red filament is coming through, no problems at all. So we'll now just get rid of it. We don't want that, we're just doing that for testing. Get rid of that off the print bed. Remember, these things are hot, be careful when you're working with a 3D printer. And if we now go back to the menu, this is the exciting bit, because we can now go back and we can do a test print. We'll go across to print, and there should be the test object on the microSD card, and there it is cat G code, so we'll select that. And what we're now going to do is to let the printer print out the first layer of the object to see if it's printing OK. And if we change the angle, we can take a nice close look at that first layer, which seems to have printed OK. Doesn't seem to be any problems there. So we'll continue the print and let the printer make a nice little model of a very small cat. So here we have our sample print, which has come out pretty well. It's not absolutely perfect though, it's got a bit of stringing on the top, and I suspect this occurred because we printed from a file intended for use with the sample filament that came with the printer. And I assumed this sample filament was Monoprice PLA, which is a type of filament I purchased on the spool. And Monoprice PLA is rated for use between 190 and 210 degrees. And as you might recall, I preheated the nozzle to 205 degrees. However, actual printing took place at 215 degrees, so the test file on the microSD card was obviously prepared for use with a higher temperature filament. Anyway, the cat is still pretty good, and since I made the cat, I've also printed out a couple of other parts which I've printed at 200 degrees, and I'm sure you will guess what these parts are. This is a spare lever for the feed mechanism on the printer. And it comes in two bits. There's a bit here which will go in the top and which clip in. I won't press it in because once I press it in, it'll never come out again. And this, I think, is printed a bit better than the cat. I'm pleased with this part. What do you think, cat? Yes, I think it's slightly better than me, says the cat. And if you're wondering, where did I get the files to make this part from? Well, I got them from a site called Thingiverse, which is a free object sharing community that contains all kinds of cool downloadable stuff. All of this brings us to the 3D printing software workflow, which involves 3 steps. The first is to obtain or create a 3D object, most usually in either STL or OBJ format. This then needs to be loaded into slicing software that converts it into another file format called G-code that actually controls a 3D printer. Lastly, the G-code needs to be supplied to the printer to allow the object to be printed. When it comes to file acquisition or creation, available options are to download a file from a website like Thingiverse, to create an object yourself using CAD or 3D sculpting software, or to make a copy of a real object either using a 3D scanner or a series of photographs and photogrammetry software. And over the next few months, I'll be posting videos on a variety of free applications you can use for all of these methods of creating a 3D object. Regardless of how a 3D file is acquired or created, for printout it needs to be converted into the G-code required to control a specific 3D printer. here I've got the G-code for the cat model we printed out earlier on the Select Mini, which, as you can see, is basically a list of instructions, loads and loads and loads of coordinate data, and there's also various settings at the end of the file. And if you're thinking, can you edit G-code yourself in the text editor, then absolutely you can. But to create the code in the first place from a 3D object, you're going to need a piece of slicing software, and here I've got Cura 15.04, which comes on the microSD card supplied with the Select Mini. And this is actually a pretty old version of Cura, but it's very easy to get up and running with the Select Mini, and I've had no problems using it. Note that the latest version of Cura is 4.12, as for some reason they restarted the numbering when they launched a new version. Basically, what we do here is to load in an object. So let's try that. Let's load in the little extruder arm we were looking at a second ago. There it is. And then when you've loaded an object in, you can rescale it, resize it, reorient it. So here I'm going to rotate it, I think, get it in a better position for printing. There we are. And as you can see, it gives us an estimate of the time it'll take to print and the amount of filament it will use. And that's based on the current settings. And those settings are over here. We've got all sorts of panels of settings. There's even more in the latest versions of Cura. But basically all we did over here is the basic settings to get things at least up and running with the Select Mini. And as you can see, we can set the layer height. I've got this at 0.2 millimeters. We've got the shell thickness, the outside thickness of the model. We've got the thickness of the base of the model, and we've got the fill density. Because normally when 3D printing, you don't make an object completely solid because it would use a lot of filament, take a lot of time. So normally the middle of the object isn't entirely solid. And 20% is a pretty typical fill density, although for this particular object, I did change this to 100% because this is going to be used potentially with a lot of pressure on it. The whole reason for printing this lever is because the one there at the moment might break, so why not print it as solid as it can be? We then got print speed, which by default is 50 millimeters a second on the Select Mini. And then we've got the printing temperatures for the nozzle and the bed, as I discussed earlier. And then at the bottom here, we've also got the diameter of the filament, which is 1.75 millimeter for the Select Mini. Finally, here is a couple of options for support type and platform adhesion. And this particular object will print very easily. It doesn't need lots of support. It's not going to fall apart. It's going to stick to the print bed very well. So let's bring in a different object to show you these particular options. And here, as you can see, we've got an elephant. And this is a sort of object that clearly wouldn't print very easily without some type of support, because the parts of the elephant are up here, under the head, under the belly. They just fall away. You couldn't print these without something to hold them in place. And so here we'd take support type and we'd put it, I think, probably to touching build plate, which will basically put supports in underneath an object but not all over it. And we'd probably have an adhesion type of maybe, let's put a little raft for that under the base of the object. And to show you what's going on there, we'll go into a different view. We'll go across here and go to the layers view. And as we can see, this object would print in 522 layers. And if I drag down here, we can see the layers building up. And you can see here we've got the support material shown in blue, which is going to support the object. We've got the outer shell in red, and we've got inside the object in yellow, we've got the internal fill. So our 20% fill density over here translates to this particular pattern we get there. We'd have a tighter pattern if we had, say, a larger fill density. Let's just show you that. And there we are, a much denser fill, which you might have noticed has increased our print time by about 2.5 hours. But give us a more solid object, use more filament. And it's worth noting it in the later versions of Cura and in many other packages, you can actually change the pattern for the internal fill. Anyway, once you've got your object ready for printout, all we'd have to do here is to click on the little save icon there, and this would save the G-code for our model, which we could then save to the microSD card for printout on the Select Mini. Now, the reason I've purchased the Select Mini is not just to use it to make functional project parts like these, which I previously purchased from online 3D printing services, but also to help out making models, which I sometimes make using molds and fiberglass resin and things like that. So, I've found a great helmet on Thingiverse. I've tweaked it using Lightwave and Mesh Mixer and various other software, and I've created a G-code file in Cura. So let's kick off a 23-hour print that will really test out the printer, as well as giving me something to experiment with. And here we are, 25 hours and 18 minutes later, we have our final print, which I think has come out very well indeed. I need to snap off all the support structure. This will come off quite easily. Most of this I'll get on with removing that, and this will leave us then with a rather nice print. But as a model maker, for me, this is a starting point, not an ending point. So I'm now going to spend some time filling and sanding and priming and sanding and painting and all that stuff until we end up with a final helmet. And the big point I'm trying to make here is that 3D printers are tools to help you make things. They don't necessarily give you the final object. You have to put some effort in to get a really good final result. So there we are. I'm very pleased to have my new 3D printer up and running, and I look forward to using it in future computing and robotics projects. I'm also, as I've said, going to make some videos on free 3D scanning and 3D modelling software, so the printer will keep popping up in those videos on the channel. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.